we have an identity problem here. So let's start from one side. I'm going to start from the left side and get to the other side. Okay, and if it's hard to get to the other side, we might also have to start from the right side and meet in the middle. Now, on the left side, we have sine and cosine. Now, we can use a Pythagorean identity to replace the sine with 1 minus cosine squared theta. And that's nice because now, on the numerator, we only have cosine. Similarly, 1 minus cosine squared theta okay, so we have 1 minus 1, that cancels out. Minus cosine squared theta plus 3 cosine of theta. 1 minus 3 gives you minus 2. So we can multiply the top and bottom by a negative. Okay, factor out a cosine from the top, and we get a cosine theta minus 2. And from the bottom, we can factor out, right, this is a quadratic, a squared minus 3a plus 2. So we can factors the cosine of theta minus 2, which is going to reduce with this, and a cosine of theta minus 1. Okay. So we have a cosine, I forgot a theta here, theta over cosine of theta minus 1. So how do we get it up to here? Okay, so note that on the numerator we have a cosine squared. And the trick here is to multiply this by the conjugate pair. Okay, note that if I multiply this with this, I'm going to get exactly that. And this becomes, because this is the differences of, right, so conjugate pairs, we're going to get differences of squared. Okay, we're almost there. If you factor out a negative 1, we get a 1 minus cosine squared theta. And that right here is equal to, by Pythagorean identity, sine squared theta. So we have the right side, and that's the proof.